Hello, good morning, good afternoon, good evening, wherever you are. I can't believe it's almost end of 2022, but we have a very special guest today. We have Rahul Singh from Anant, and basically, he's going to be doing most of the workshop today. We usually don't have a lot of kind of working with big data kind of workshops. But today is going to be a little bit different. But before we dive into the workshop, I just want to make sure everybody can hear me well. You can hear two voices. Rahul, do you just want to say something so that we have only two voices and no more than two voices, because sometimes the echo is very irritating. So
Sure. Yeah. Hey, thanks for having me, Rags. I appreciate it. Yeah, this is great. I mean, Cassandra is big data, so it's at some point you got to have some talks about big data. So I'm glad to be adding to your
yeah, actually,
content
good
here. This is
point.
great.
So what I meant is like have a little bit more of the big data ecosystem. That's kind of what I meant, and we're definitely gonna see a lot more today. Having said that, this is as
Yep.
many of it's going to be a hands-on workshop, and let me go to the next slide. Okay, my name is Raghavan Srinivas, and hopefully you're going to be able to see me. And I work as a developer advocate at DataStax. I come from the Java background and the Kubernetes background. Are you guys seeing an update of the slides? Rahul, do you want to confirm if the slides are getting updated?
Um,
Okay.
no, it's
Yeah,
still on the
so
first one.
it's pretty strange why this is happening. And oh, okay. All right. So now we should see that. Okay.
Yep.
So
Got it confirmed.
I'm a big fan of distributed systems. I really love to teach and communicate. But one thing I'm really passionate about is the inner loop, which is really about kind of the productivity gains you can realize. Um, and I use Quarkus, other things. But primarily, I love to teach and communicate. I also am a mechanical engineer. My undergrad was in mechanical engineering. I like these workshops because not only do you all learn, the attendees, thanks for taking the time again, but I also learn a lot as well. So with that said, let's introduce the rest of the team, which is behind the workshop. A lot of effort goes in. We have workshops typically every Wednesday around the same time. We have a few more workshops till the end of the year, end of the month, end of the year, and then we're going to start off with a boot camp in January 2023, which is typically how we roll. Um, you can live stream this on YouTube. Um, Typically, we used to have a Twitch as well, but today we don't have a Twitch. So you basically look at YouTube and feel free to chat on YouTube. Either Rahul or myself or any of our teammates are going to be on the chat and glad to answer your questions. For more detailed questions, however, we suggest you use Discord, which is for more long-lived kind of discussions and for more detailed discussions. And not only our developer advocate team, but the entire data stacks is going to be there to kind of help you out. Okay. Um, what is a DataStax devs workshop without Mentee, right? So some of you who have been here before, you know what Mentee is, and I'm going to talk about that in a second. But with that said, we also have a number of resources. I say we are living in the golden age of developers. We have so many resources available for us, right? And most of it is pretty much free, right? So you can go to GitHub. GitHub.com/datastacksdevs, is probably the right way, probably the way, way to get started, because there are a whole bunch of repositories in there. Today we are using a different GitHub repository, but we will talk about that in a second. We use Gitpart in most of our workshops. The nice thing about Gitpart is you don't have to install anything. And I know that Rahul was instrumental in getting us started on Gitpart, in our initial journey. So thank you there, because I'm a big fan of Gitpart as well. And I'm sure if you've never used Gitpart, you will appreciate this as well. We're going to use ASTRA DB, get that out of the way initially, and then Rahul is going to jump into the meat of the workshop. So a very brief introduction about Cassandra, ASTRA, and so on, and then we're going to get into the meat of the workshop. With that said, let's do a mentee, and give me a second so that I can switch my slides. Oh, did I do something wrong there? Question 6 of 6. No, that's not a good idea, right? So you already have a hint, but let me see if I can. All right. So let me go ahead and present. So basically what you're going to do is you're going to go to www.mentee.com and use the code 3518069. Ideally, if you can do it on your mobile phone, that's the best. Okay. I will also put in the code here, but I could also do this. You can use this QR code as well. But mentee.com 3518069, probably the easiest way, right? Okay, let's get started. Let's see if people are joining. I don't think there are people joining yet. I only see a few people joining. Let's get some more people going. I don't know, we have quite a few viewers. So let's give it a little bit of time. Thank you for those who have joined already. And remember that we usually have a quiz at the end of the workshop. So great idea to kind of get used to it, because when it comes to the quiz, you not only have to get the right answer, but you also have to be fast. A lot of times I've tried to be on the quiz, and I'm just not fast enough, right? So getting used to it right now will help you win some swag later. And today we have a really cool looking swag that I'll show. And thanks for Anant, for doing this. Thanks to Anant and Rahul for doing this as well. Okay, so with that, the first question we ask, and I really like to see the dots pop up everywhere, right? Where in the world you're from? You don't need to be precise. Is that Canada? That's the first dot? Looks like it, right? Yeah.
Looks like, yeah, Newfoundland, okay. I think.
Quite a few from India, one Africa, one in Indiana, yeah. Maybe, yeah. It's always cool to see these dots, right? Let's see a few more dots. Nice. And again, that'll be great. A few more from Canada, wow, okay.
Broad, across the world, actually.
All right. That's nice. Welcome from wherever you are in the world. Any of you rooting for your favorite team to win the World Cup soccer tournament? Just feel free to put it in chat. If your team is still alive, if your country's team is still alive. Unfortunately, India never qualified. That's where I come from, and the USA, just got eliminated. What's your favorite team, Rahul?
India's all about the cricket,
That's
man.
That's right. Yeah, but I don't know if you heard, India lost to Bangladesh last week. So, yeah.
Oh.
So it's not great from a cricket perspective either. Okay. So we do ask you some questions. What is your experience level with Apache Cassandra? This is so that we can kind of tune our presentation or tune our emphasis. There is one experienced developer or administrator, a NoSQL guru, and that must be Rahul. Or Okay.
I'm not doing the mentee. I don't want to rig the game.
Exactly. Yeah. All right. We have a NoSQL guru, so watch out, Rahul. All right. All right. Give it a couple of minutes. Okay. Move on. And again, if you want to join this, if you're late, it's 3518069. And like I said before, we're going to have a quiz where it really matters that you do it on time, as fast as you can, but also answer correctly. Okay. Question 2. What is your experience with Apache Airflow? Is this the first time you heard of it? Are you an experienced developer or administrator? Again, watch out. Okay, as we thought, most everybody is kind of a beginner on Apache Airflow. Okay, but we have a few, and maybe you have some tips for the experienced developer or administrator as well, right? It's always great to have these questions because it kind of gives us an idea of who the audience is, and usually, we have an assumption, but sometimes, we are thrown off, and we try to correct as we go along because we want to make it as applicable to the audience as possible. Final question. Is this your first DataStax Devs workshop? Yes. 2 S's, 3 S's. We do get a lot of repeat DataStax Devs attendees, but last count of how many workshops I attended. All right. 5th or more workshop. Okay, that is cool. So the majority, are new. I forgot to put on the quiz music. I will add that right now if I can. All right. So the majority of them are new to the workshop, which is kind of what we expected. Any comments, Rahul, on how this kind of looks? Anything that surprises you?
Sure. Yeah. No. It's good to have new people joining the community. Cassandra is one of those things that people don't who are new to it. First of all, don't understand how awesome it is, but when they see a workshop like this, especially showing how easy it is to get started with ASTRA without having to have your own cluster, I think it's great to have new people involved. So yeah, welcome. Glad to have you guys.
Okay. So keep this going, the mentee, because we're going to have a quiz later, okay? But now we will move back to the presentation. So give me a second before I can get there. All right, we are done with the mentee. So moving on. All right. So today's challenge is we're going to do some ETL, although Apache Airflow is not an ETL tool, right? And Rahul will talk about this. But basically, we will talk about kind of automating operations. Because whenever you talk about ETL, kind of it conjures up this thing about manual, kind of having to do all that. And whenever you do something manually, it tends to be error prone. So, automating it is going to be a lot better. And let me stop the music so that it's not irritating to people. All right. We will build all this on Gitpart, as you can see here, and we'll have a Spark master and so on, which we'll walk through during this session. And like I said before, it's all hands-on. You're going to be doing this. After a very brief introduction to Cassandra, we're going to go through the rest of the agenda. And Rahul, do you want to talk a little bit about this? Yeah.
Sure. So one of the things that I like to do is explain to people why something is important. So we're going to just spend a little bit of time on open data platform and why Airflow has become such a popular tool, right, in the open data platform world. And then we'll cover a little bit about Airflow and Spark. But the meat of the presentation really is about running ETL processes in Spark, but coordinating it with Airflow. And also, I'll walk through some real world example, I'm not going to have the code as a hands-on walkthrough, but to do more advanced operations than, for example, cleaning information in Cassandra, that's a common need. And you'll see how useful it is to leverage Airflow and Spark as an ecosystem.
Perfect. So with that said, a very short introduction of NoSQL. It's basically a catchy hashtag that people came up with, and it kind of stuck. It's really about everything that is not SQL. Okay, SQL was very popular, but the problem with SQL is that you cannot keep scaling vertically for forever, right? You kind of keel over at some point and you're going to fall off, right? The NoSQL is really about horizontal scaling. It's really about kind of leveraging commodity hardware and being able to distribute your data, but let the software or the platform take care of it. And that's why this term NoSQL has become popular. And if you think about this, June 11th, 2009, this was about the time that cloud also kind of started catching up, right? But the nice thing about NoSQL and the cloud is that there are a lot of similarities, and it's a nice synergy between NoSQL and the cloud. And you can take advantage of both when you kind of combine them. Because typically, if you think about relational versus NoSQL, relational is, like I said, is about scaling vertically to a point, and then you basically hit the limits. With NoSQL, it's really about horizontal scaling, easy to scale, and really, one of the downsides that you may have heard about people talking about NoSQL is that there is no concept of asset transactions, right? But even that is changing in today's world. You might have heard, you might have seen some presentations in Cassandra Day where we talked about asset transactions, and we have a Cassandra Summit coming up in March where we're going to have more details about this. But again, we will talk about that later again. But the point again I'm trying to make here is that some of these lines are actually blurring a little bit, and some of the relational databases you can also do some scaling, but typically NoSQL was really born in the cloud even before the cloud was there. Kind of, if you want to think about it that way. Okay, you might have heard about this. It's called the CAP theorem, or also referred to as the Brewer's conjecture. And essentially, if you want to think about distributed system characteristics, there is consistency, availability, and partition tolerance. You can only have two of these in a failure scenario. When there is no failure, everything hunky-dory, you can have all three, no problem, right? But when you actually come into a failure scenario, which is typical in a distributed system, you have to pick two of the three, or you have to sacrifice one of the three. Okay. Typically, none of the NoSQL systems really sacrifice partition tolerance, because what happens in a partition tolerant or something that does not have partition tolerance is anybody can notice the inconsistencies there, right? On the other hand, if you sacrifice consistency, there is still a concept of eventual consistency where I'm not on top of the leaderboard for 15 seconds. Big deal, right? But maybe it is a big deal, right? And that is why we are adding ACID transactions as well. So you can tune your consistency levels and so on. But if you make it, ACID consistency, then you may not be available for a certain amount of time. So in other words, you always have to sacrifice one of the two. Okay. And the ecosystem kind of distributes itself, right, into either a AP system or a CP system. Like I said, nobody really gives up on partition tolerance. So you'll see a number of these different databases or NoSQL databases kind of aligning into AP or CP. But again, there is ways in which you can say, I want different levels of consistency, and depending on the different levels of consistency, like whether it's eventual consistency or very strong consistency, your system may not be available and so on. So again, the point is that it's for big data. It's the nice thing about Cassandra is that it basically scales linearly. And Rahul and I were at AWS reInvent. We spoke to so many customers about Apache Cassandra, and one of the things they like, including the people like who came from Apple, Netflix, Priceline, and so on, is the fact that it linearly scales. Many of the NoSQL systems, they go to a point and then they kind of level off. Not so in the case of Cassandra. Okay, but I know that you guys are waiting to get your hands on, so let's start with the hands-on. Okay, so to do that, let me bring up my. So this is the GitHub link. If you just put a pound GitHub, and I'll try to put it myself, you should get the link on chat. Okay, if everything is working okay. Let's see, should work. Okay, so there you go. It was a little bit late. Okay, and all that I do is just follow along on this, GitHub link. Okay, so it's github.com/Anant, which is the company, and example Cassandra ETL with Airflow and Spark. So what we're going to do is we're going to open this in Gitpart. The moment you open in Gitpart, okay, so open link, I'm going to open link in new window, but I've already opened this, so yeah, what the heck, let me open a new one. Okay, and basically it'll ask you for the GitHub ID, or you can use I think you can use GitLab and others as well, but GitHub is probably the easiest. Okay, and what it'll do is it'll bring up this Gitpart link. Okay, and I opened it in a new window, but you can do it in a new tab, whichever works for you. And you'll see here that I have the repository, and if I do a git remote, right, -v, it'll give you the link as well. Okay, so basically it's linked here, and if I change any of these, it's kind of you can use it like a git terminal, if you will. So if you look at this is really Visual Studio on the cloud. You have a file explorer window, and you can edit any of these. So if you click on this, it shows you how you can create tables and so on, and you can edit this. Okay, so if I do something like that, or setup.sh, and so basically this is the editor, and then you can run commands here. Okay, so if I do an ASTRA DB list, it's probably going to fail because I haven't installed ASTRA yet, but I'm going to install it in a second. Okay, all right, so let me go back here. Okay, and continue. I'm going to create a database name called workshops. Okay, and a Airflow demo, and again, all that you need to do is click on this link. I've already created all this. So I've already created a security token. I'm going to install the ASTRA CLI now. Okay, so I'm going to go here and I'm going to install the ASTRA CLI. Okay, and then everything should be hunky-dory. All that you need to do is grab the command from the GitHub and just add it here. Okay, so let me go to two small heads here and get rid of the quiz music. Okay, so this might be better when I'm doing a demo. Okay, so it worked, and now what I'm going to do is make sure that ASTRA is in my path, right? So I'm going to source this, and let me bring this up so that you guys can see it. Okay, and it asked me to enter an ASTRA token. Okay, so when you go to ASTRA, you can create a token, and the way you create it is, is pretty straightforward. Let me show it here. But all the steps are in there. Okay, if you go to astra.datastacks.com and just sign in. Okay, and if you go to your organization settings, okay, token management, okay, and select the role database administrator. It could be a little bit more fine-grained, but we just pick the database administrator, and just make sure you use this you save this client ID, client secret, and token somewhere. You can just say download the token details and it'll be there, okay? Or you can copy paste it. You can do whatever you want, okay? Because once you navigate away from this page, you're not going to get this anymore, okay? I've already cut and pasted this, and let me see if I can find that. I've kind of sneaked it in, so let me see if I can find it. And I'm going to put the token in there, okay? So just give me a second to find that. All right. And I'm going to put the token in here, okay? And hopefully it's all going to work. So I'm going to get rid of this. I don't really need that, okay? I put the token in there, and I'm good to go. And I'm going to clear this. Okay. So now I should, if I list the, if I run the command ASTRA DB list, I should be able to see it. Okay, so you can see, there are 5, different databases. One of the key things I forgot to tell you was that you get a $25 per month free credit. So you don't have to put your credit card. All that you need to do is put in your email. That's it. Or you can use your GitHub link as well. I use my email. And then you get $25, which is actually pretty good to run some fairly significant production workloads, believe it or not. Okay. So what I did to summarize was kind of talked about NoSQL, talked about Cassandra as the linear scalable NoSQL database, right? And then what we did was we brought up Gitpart by just clicking on that link, right? And then we created a token in ASTRA, but keep the client ID and secrets as well, because we're going to use it, and Rahul is going to talk about that. And once you're done with this, notice there are 2 windows, the terminal window, there are 2 terminals, and we'll be kind of going between one and the other. The all commands window and the run airflow window, so Rahul is going to talk about all that. With that said, let me go back to the presentation. Okay, let me see where it was. Okay, so with that said, Rahul, it's all yours. Let's see some thumbs up on our in our chat to see if any of you are able to create the database. And if you're not able to create the database, please reach out and chat, and we'll be glad to help you. One thing I forgot to mention was you need to use a link, and maybe this is relevant. Let me show that really quickly. Let me go back again to the ASTRA link. Okay, you have to use a free tier. Not all of them are free tiers. Okay, so if you want to create a new database, okay, you have to pick the North America and a region that is free. Okay, some of these are not free. The best thing to do is just use US East, North, like North Virginia. Okay, like if you use Google Cloud, okay, and use Monk's Corner. This is what you want to use, okay, and you'll be good to go. Some of these might be locked for you. For me, it's all open because I'm special, right? But some of these might show as locked. So what I would do is just pick Google Cloud, North America, and Monk's Corner to be able to create your database. Okay, I think I've talked enough, and I will let Rahul drive it. So let me make sure that your screen is showing up. Okay, just give me a second. And I will.
Thank you. I appreciate that walkthrough. And give me 1 second. I'm going to get my Skype sharing. Sorry, Siri is always listening in on me.
You bet.
you should be able to see my full screen now.
All right, give you a second.
And yeah.
All right, you're good.
Well, excellent. Well, thanks again, Rags and DataStax for having us. Just a little bit about what our company does. We help platform owners just think big. So we help them with their platform design and essentially companies that have a global customer base. And DataStax and ASTRA are great partners to help us give people what they want. And the way we do that is, we have a playbook, which we're going to preview a little bit about. And in our framework, we use tools like Cassandra, Spark, Kafka, Airflow as part of our framework. And ultimately, once you build a platform, we have an approach for how to manage it. And even if you're using a SaaS system like ASTRA, you're going to have other systems and it becomes complicated. So you need a little bit of a guidance. So that's what we do. We help people with their big platforms. We've helped quite a number of customers over the years, a lot of brands that you probably use. We work with them, and it's just like Cassandra. I was explaining to Cassandra at a holiday party yesterday, and I said, yeah, pretty much every app on your iPhone, it's powered by Cassandra in the background, or Netflix, Spotify, Walmart, Priceline, everything you imagine as a global company, they use technology like Cassandra, and that's the type of work we work. Those are the clients we work with. A quick preview of where this playbook and framework fits in. For every challenge, we have a tool. So when we go from a business challenge to how to make it into a platform, our playbook is about how do you design the platform, how do you integrate real-time data with the rest of your systems. Once you know what your design is going to be, what your platform is going to be, is it going to be AWS, is it going to be Azure? Ultimately, then it's what specific components need to be used. And if you're in this big data or data and analytics ecosystem, it's hard to figure out what tools to use. And so that's where our framework comes in. We tell people, here are the different categories of tools. Here's what you can use in this category. And we're going to focus mainly on the framework today, specifically Airflow and Spark and how it works with Cassandra. And how we do that, we help people with professional services, and we help them coordinate their managed services. We don't want to reinvent the wheel. There's companies like DataStax that have ASTRA. We recommend people use something as a service so that you don't have to basically do busy work. When you have a company like ASTRA providing a database as a service, that talent that would have gone into managing the SRE, managing the DevOps, you can actually focus on other things like data engineering and data ops. In fact, there was a talk by somebody at AWS reInvent last where they had migrated a bunch of databases to the cloud. And they were saying, well, what do we do now? We're DBAs. What do we do now? Well, the new job for the DBA is data engineering, data ops, infrastructure as code. And that's really where your innovation should be going, is in new features, not like running servers.
Take care of your customers, right?
Yes, exactly. Take care of your customers. I give the big picture view because that's just the way I think. I always want to know why I'm doing something. So when we work on data and analytics platforms, why do we do that? Well, because business platforms have lots and lots of systems across many different areas that connect people, process, information, and systems. And we have this vision of what we say is enterprise consciousness, which is real-time data across users and processes and systems, and technologies like Cassandra, Spark, Kafka, Pulsar, they help us get there. But data analytics are at the heart of any business platform. And every company has some system. The bigger companies need technologies like Cassandra. The modern open data platform is a relatively new concept. It used to be, proprietary technologies like SQL Server, Oracle, and you did everything around it. And then there was Hadoop, and Hadoop had 50 different tools to do what you needed to do. And so now what we see is a movement towards an open data platform which uses open core or open source tools, and you kind of bring them together to do what you need. Instead of getting it from one vendor, you're kind of piecing it together. So our playbook is about helping people figure out what to use, right? And Cassandra is at the heart of that. we love Cassandra because it has this idea of a data fabric built in. And you can run it on different clouds. You can run it on different systems like containers and VMs, on-premise, etc. And what I mean by a data fabric, and Cassandra really, alongside databases like Couchbase, they made it possible to have cross data center replication. And that's huge. And we're going to talk a little bit about how, when you're running a Spark job to do ETL on a different data center, you're not going to be impacting your transactional traffic, right? So if you're using ASTRA, you don't have to worry about all this stuff. But because ASTRA just scales, horizontally as you start to use more and more of it. But the idea of Cassandra as a data fabric came about because Cassandra scales infinitely horizontally. You can put more and more workloads on it, and everybody can have access to that information in real time, whether it's an analytical process, a transactional process, a machine learning process, you name it. And there are native offerings like Cosmos, but they're like prohibitively expensive, and that's what we see. People will use Cosmos and they'll say, this is too expensive for us. So then they'll maybe go to ASTRA, or maybe they'll do Cassandra, right? Because, well, quite honestly, those companies are doing something for everybody, and each customer that uses Cassandra, they have some special need for it. Technologies like ASTRA make it easy to do those special needs in different scenarios. A data platform is not just a database, right? It's actually a confluence of lots of different things. There's a stream involved generally in a mature data platform. There's a scheduler, and that's what Airflow is. It's a scheduler. There are internal APIs. There are external APIs that you may be bringing data into or sending data out to. But it's not always just like, what Rags was talking about. You have not only relational or not only SQL systems alongside with SQL and relational systems, alongside with data lakehouses or data warehouses. And that's really where inside the core of the data platform, we need technologies like Airflow to help us move, or at least to coordinate the pipelines of information, right? And we want something that's repeatable, automated, not error prone. So you start to understand that, Airflow is a part of a much bigger picture. It's not just about Cassandra and Spark. It could be used to get data out of Cassandra, put it into a data warehouse that you're using, like Snowflake, for example. Or it could be taking data out of a data lakehouse, like S3, Delta Lake, etc., and put it into Cassandra, right? So there's a lot of different use cases. Well, I just want you to understand that we're going to talk about like one little part of it, but it can do a lot more. We focus on distributed real-time components, right? Distributed real-time means things that scale infinitely, things that work with other things that scale infinitely. Cassandra, DataStax, ASTRA, they work really, really well with Spark. But Spark can be run by Google for you, right? Google Dataproc is like a Google version of Spark, or AWS EMR. There are other technologies like Presto that work well. So in an open data platform, our focus is in distributed real-time components. There's a lot of tools that are out there that are open source that we don't really care much about. It's just, well, everybody else does that, right? But how do you choose from that landscape, right? Like, there are so many different technologies out there for data and AI, right? This is just data and AI. There's even more technologies in general from a software perspective, like CRM, right? Those are like millions of options. But in data and AI, there's a lot of options, a lot of open source options. Even the Linux Foundation's data and AI landscape, there's so many different tools out there, right? So you're not going to need all of them because, quite frankly, a lot of them do the same thing. So how do you choose these tools? Well, we do a lot of research and we ask ourselves, what is the industry using? We don't want to reinvent the wheel. And when we do research on open tools and open platforms, we notice these patterns over and over and over again. We see technologies like Spark everywhere. We see technologies like Airflow everywhere. And I'm not saying just technologies like Spark. We see Spark everywhere. We see Airflow everywhere. And they work well with other tools. Like Amundsen is an open source data catalog that can store data of the whole data ecosystem in your company inside Cassandra and Janus Graph or DSE Graph. But guess what it uses to collect all the metadata? It uses Airflow. It uses Airflow to basically populate all that data. So if another open source project as mature as Amundsen is using Airflow, that's really the signal that I look for, is who's using these tools. The other signal for Airflow is there was an Airflow conference, and I think there have been a few in the last few years. And who are the people speaking about Airflow? You got Uber, you got Apple. These companies are using Airflow, and these are also the same companies that use Cassandra, right? So they need this technology because they don't want to reinvent the wheel. And ultimately, what we do is we put all these things together and we categorize them, and we look at the open source strategy, we look at the Google strategy, we look at the Amazon strategy. That's because not every company is just going to use all open source tools, hook, line, and sinker. They're going to maybe use a lot of things on their cloud of choice, and then they're going to need something different. The benefit of Airflow is that it is becoming a standard. Okay, so there is a company called Astronomer, like DataStax supports Cassandra. Astronomer supports Airflow, but there's a managed version of Airflow from Amazon. There's a managed version of Airflow from Google also. So technology, specifically, if it starts to be managed by the clouds, that's another good signal that, okay, there's a critical mass enough that people need it, that they're going to make it a commodity, right? So you don't necessarily have to run your own Airflow instance because these clouds will help you do it for you. We're going to focus in our called Playbook. There's a design component, there's an evaluation, which framework tools, and then there's finally like how do you execute. We're going to focus on data ops, right? This is kind of where Airflow really fits. Is how do you orchestrate and operate these data operations, and then in terms of operation, right? There's the how do we set it up? How do we monitor it? Well, in terms of operation, Airflow can also be used for certain administrative functions. And then finally, when you put it all together, when you put all the Lego blocks together, we come up with a reference architecture where we say, okay, well, if you're doing real-time, if you're doing real-time data in, real-time data out, real-time analytics, real-time machine learning, this is kind of the technology stack to use. Here are all the components. When you put them together, this is what it looks like. Now, in the data modernization aspect of platforms, there are a lot of tools that we're not going to get into today, okay? But there's a lot of tools for ETL. There's a lot of tools for reverse ETL. And what I mean by ETL, it's not from your CSV file into Cassandra. I'm talking about data coming from Salesforce, getting it into Cassandra. Data coming from Cassandra and sending it back to Salesforce, right? That's reverse ETL. There's a lot of open source tools out there that can help you do that. But on this left column here, I have Amundsen and Airflow highlighted, because Amundsen is an open source data catalog, so is DataHub, but Amundsen uses Airflow. And in a mature data platform, you eventually have a data catalog, and maybe that can be another talk, how to set up Amundsen on ASTRA. But today we're going to focus on Airflow. And the last thing about our playbook, which is really important, is the reason orchestration, automation, continuous integration, and delivery, the reason it's important in the setup column of our approach is that people across the board who are in development, operations, architecture, it allows them to be reliant on that process. It allows people to easily get trained on that process. You don't have to be an expert if something's automated. You can just kind of start using it, and you learn more and more of it. We came up with this schema because ITIL, even though it's really great, I feel like only the largest companies in the world can implement ITIL. If you don't know what that is, you can Google it. It's called IT Information Systems Library, Infrastructure Library. It's a way, it's a patterns and practices for how to manage technology at scale. Well, you know what, when we were working with our clients, a lot of the folks that are in the startup world or in growth mode, they don't quite get ITIL. They're not quite there. You're not a company that's been around for 20 years, right? So they need some guidance on how do we do this so that when employee 5 leaves and employee number 50 comes, that they're able to kind of quickly get involved. So documentation is a very big part of our approach. But the best part about automation, especially with a tool like Airflow, is the documentation can be in the automation. The way something runs and how well it runs can be integrated in there, right? So when you put it all together, we talked about a bunch of stuff. Airflow plus Spark is one combination, but Spark has different languages, and we can get into that. So you can do a Spark program in Python, in Scala, in Java, in R, even C# if you want, in Kotlin if you want. All of that together around, combined into a Airflow DAG, it makes a data operation system for you for Cassandra, and it's good enough. For a lot of the things that you do right now with the cron job, you can replace it with Airflow, and you can do a lot more. In fact, we'll show some automated systems that we've designed to allow companies to make it self-service. So like, I need this data deleted from production. Well, you want to have some approvals in place, but it allows people to do this in a semi-automated fashion. So you can put more intelligence and organization around your Airflow DAGs if you want. Or you can do the simple thing that I'm about to show.
You may not have heard of DAG. Do you want to spell it out?
Yeah. Yes, exactly. And I'll show a picture of what a DAG is. So a DAG is, it's shorthand for, it's an acronym for Directed Acyclic Graph. Yeah. And DAG basically, the way I describe it is it's directed, meaning it goes one way. And you can, directed meaning there's a direction to it, right? It's not, and then acyclic means it does not infinitely keep going. And then it's a graph, meaning it's a collection of things that go in one direction. So why is that important? Well, we use DAGs in Airflow. We also use DAGs in Spark. It's the way to farm out complex workflows and tasks and execute them at scale. That's the only way to do it, is to plan out the work. So a DAG is kind of a plan of work, a plan of tasks. And when you see the visual, you'll understand what I'm talking about. And when we get into the hands-on, you'll see that as well. You'll see what the DAG looks like. So what is Airflow? It's a scheduler. It's used for scheduling and automating workflows and tasks. So I want to make sure that you understand that there's a difference between automating ETL and doing ETL. So that's why we have a separation in our code. There's some code that is doing the ETL in Python, but the Python code we have in Airflow, it coordinates that task. It takes care it takes care of basically sequencing the work in a logical way, right? You can use Airflow to do a lot of different things. You can use it to manage a pipeline of ETL tasks or things that are dependent. So for example, 3 data sets come in from external sources into S3. You're collecting it via one type of task, right? Then those 3 data sets get combined into another data set. Now, you can do that yourself. You can have cron jobs that run for those 3 earlier, and then you can have another one that runs like every 6 hours. But with Airflow, there's intelligence behind it. It won't run the job that's dependent unless and until all of the previous tasks are done. And you can go all out with that. You can do simple workflows like we're going to do, or you can do complex ones. What I like about, and you'll see the GUI, is that you can choose for tasks to be run one time at a particular date in the future with a certain business logic, like every Sunday except on a holiday or stuff like that. Or you can do a simple cron, use to cron to run scheduled tasks on your cluster to do certain things like ETL or export and archive of information. You can do that same syntax with Airflow, or you can say things like every day, right? Or you can say every month at this time. And all of this is managed in this GUI so that if there are errors, if there are things that are taking longer, you can see it all in one place. And we're going to explore the UI when we get started, but this is kind of like the top level of Airflow. Remember, it is not an ETL tool, okay? It is a tool that helps you coordinate ETL processes, and it can do a lot more. Architecture is very simple. There is a database that it stores information in. Technically, you can use any database, but Postgres is the is a recommendation. We have a web server that people can use to see what the jobs are, how long they're running. The web server also has an API, so you can actually automate the automations in Airflow if you wanted to. And there's a scheduler that runs in the background, and there are different executors. We're going to use an executor that just runs on one computer. But if you use one of the other executors, like the Kubernetes executor or the Celery executor, it is possible to have many workers on many computers doing this for you. So Airflow itself is scalable. It's going to be working against big data, against things like Spark, which is already a distributed system. But Airflow itself can scale, and you can have hundreds of jobs running on Airflow across many computers without an issue. And how does it do that? What is the DevOps of Airflow? Well, your code, which is a Python file, if it lands in the right directory, Airflow scheduler will pick it up and it will just show you, hey, I've got a new DAG. What do you want to do with it? Do you want to unpause it? And it comes with a bunch of like examples. So, you know, we'll see the example ones and we'll use ours for the hands-on. Here's a quick snapshot of a DAG. So, for example, you want to analyze some information. So you have an ingest process. You analyze it to make sure everything's good. You check the integrity, and only after the integrity has been checked, you can then run a fork of tasks to then save the data and report it. And at the same time, you can say if there are errors found, right? If and only if there are errors found, go ahead and describe what integrity issues there were and email that out. And the fact is that you can have so many forks in there, you can get it really complicated. The benefit of having it as a DAG is, you see these green lines around these like boxes here? If a particular task in the whole DAG is slow or it's pending, it'll have a different color. Or if it failed, it'll be red. So in one quick dashboard, you can see your whole workflow, whether everything is green or if there's some yellow or, and then there's actually about 12 or 15 different states like pending, skipped, active, which, we have a pretty simple DAG, so we're not going to see everything, but you get to see different views of your DAG. This is just one view. There are other views that give you more intelligence. I'm going to just turn off my watch.
Man, it's really responsive. Listens to you, even when you don't want to talk to it.
The rise of the machines, it starts with Apple Siri, seriously.
Exactly.
It wants to help. It wants to do our jobs for us. Yes, exactly. GPT-3 will just completely do the talk for me. Here is the main dashboard when you log into Airflow, where you see all of the DAGs, whether they're active or paused. You can unpause it by clicking this toggle. These are basically showing you the previous executions. If it was good, if it was bad, you can force a run. You can refresh the file. It's pretty intuitive. They've added more and more tools in here, but I find it that once you get introduced to the UI, you're pretty much good to go. You can just continue exploring and learn what's going on. It's not
is there a command line for Apache Airflow?
I can talk.
It's mainly through the GUI.
So there are command line tools to get it started. There are command line tools to execute certain jobs. It also has an API. So it's UI, command line, and API. So you can automate the automation through any of those ways, with the command line or the API. Hey man, we're either building robots or we're maintaining them, right? That's the future. And I could talk about Apache Spark and go super deep into it, but I'm gonna leave that for another session because Spark is it's more than a Swiss Army knife. It's like the Swiss Army. It can do so many things for you at a very high level. But basically, Spark is a catch-all for when you need to do big data processing. It's kind of the first thing you go to, especially if you want to get data into Cassandra or get data out of Cassandra very fast, lots and lots of information. It can also do streaming, we're not going to use the streaming function today. But Apache Spark is a batch system that is the next generation after Hadoop. Hadoop had MapReduce and Yarn. Spark builds upon that and makes it easier to do big data. So these days, even if you're using the whole Hadoop ecosystem, you're likely using Spark on Hadoop. In our case, we're just going to have a local Spark. Spark, as I mentioned, also has a DAG. It has a directed acyclic graph for the tasks it's running, which are more fine-grained, right? Like if you have a math operation that needs to run on 20 different partitions across 20 different servers, internally Spark will make a DAG and it'll keep track of that work and it'll execute it. Most people don't get into that level of detail, but I just wanted to clarify, since Airflow has a DAG and Spark has a DAG, and I wanted to make sure that you guys knew the difference. Like Airflow, there are lots of different connections to outside systems. So Airflow can connect to different databases and different systems to do operations. Spark can basically connect to everything out there. There's always like Spark connector for Apache Cassandra allows you to connect to Cassandra from Spark. But there are connectors for Kafka. There's connectors for Hive or data lakes built on Parquet. You name it, there's a connector for it. Lots of libraries. There's other tools inside Spark, which again, we're not going to get to, but it has a graph processing library. It's not a graph database, it's a graph processing library. It has a machine learning library. It has full-fledged data frames to do operations in memory and then either send them back to the source system or to send them to new systems. Basically, you can anything with big data.
So Anant,
you can do it in Spark.
I'm sorry, Rahul. Basically, Marcus has a question, and he was like, are these diagrams in GitHub? And I know that we're going to add the slides. We were just waiting for it to be completely up to date. And actually, Rahul is looking for some feedback. If you have any feedback, just put it in there. He'll update the slides and put it back in the same repository. Correct?
Yep, exactly. And a lot of the stuff that I use, I don't necessarily recreate. There's our public resources. So like, for example, the architecture diagram that I was showing you, that's straight out of the Airflow documentation. And I'll actually show a few more. But yeah, this deck will be put onto a GitHub. You'll have access to it. And the DataStax team will make sure you get the right links. Okay. Thanks. Sorry, I have the chat here, but I'm so focused on the talk that I'm not getting a chance. Thank you for bringing that up, Arags. I appreciate it. So what I'm going to do is to scan over. When I say it's a bonus round, what I'm doing here is explaining a advanced use of Airflow in a way that I think a lot of people can get their mind around, because there's a challenge that I see all the time with people that are using Cassandra, which is they need to do data hygiene, which is beyond TTL. And when you have billions of records across terabytes of data in Cassandra, you have to basically iterate. And if you don't have the right indexes, even then, even if you have the right indexes, you have to basically do a Spark job to do these advanced things like deletion or manipulation of information, right? Let's say you found an error in your logic. Hopefully you don't, but let's say you found an error in your logic. You need to update data across billions of rows. Spark would be the way you do it. So in big data, there's lots of big data options, right? You have your cold data stores and you have your hot data stores. And when I put star on these items, these all use CQL. So what I'm showing you, you can use with any CQL compliant system. But the other thing is that this approach with using using Spark with Airflow to clean data or to do some hygiene, you can actually take it and apply it to any of your cold data stores too, like a data lake, right? This is the same general practice. So it goes, what I show you goes beyond just Cassandra and cleaning data in Cassandra. It's actually any system. When you are doing big data, generally you try to clean your data before it goes into your database, right? You remove duplicates, you get rid of like extra information, you fix structural issues, all of this stuff. You do it as part of your data engineering, right? Your data wrangling. But you may still, even if you do everything properly, you may still have to do something after the fact, after it's inside your big data system like Cassandra. It could be that you have revisions of information and you have a revision eviction policy that is not simply, oh, let's put a TTL on it, right? Or you need to move a customer's information from one cluster to another cluster, right? It's a multi-tenant system. You need to enforce GDPR, the right to be forgotten. I want to delete all my data from your systems, right? And so you can't just, at least not now, you can't just go to Cassandra CQLSH and say, delete from this table where this is equal to this, and it'll magically do it, right? It doesn't do that. Or, update this thing to this value, and you have some like complex subquery to basically find out where to update that information. So the things that we were used to in the relational world, we just can't take it for granted in non-relational. And in SQL, you would say, hey, delete, right? Here's my where clause. And then in your where clause, you have another subquery. And everything would just work, right? You just do it. Even if it took 12 hours, I mean, you have those things, right?
Yeah.
It's a 12-hour job to delete data on SQL. It will go and it'll finish. Or in Oracle, it will finish.
You're right, yeah. At least you can have a query which does that.
Yeah.
But yeah, you need to be a little bit more mindful in NoSQL where performance matters, right?
Yeah.
So, yeah.
But performance matters, and it's actually not as easy. This particular type of delete operation,
Correct.
It just won't work. It's syntactically it won't work in SQL, right? Now in Spark SQL, if you're connected to a data set in Spark, some data sets, they support this type of deletion. Okay? Like, for example, in Databricks, in Apache Spark inside Databricks, they support this type of syntax for Delta Lake because, Databricks made Delta Lake and they made it, right? But you can't rely on this type of syntax even inside Spark SQL, which is the ability to do SQL with joins and wheres and all that. You can do that against Cassandra if you're using Spark, right? That's whole another talk. But you can't rely on this delete operation. So what do you do then? What if you want to do deletes on tons and tons of information? How would you go about it? Well, you can make a function, right? And this is a Scala function, which given a particular where clause, it's reusable. And I'm going to bank on later on, because if you have a function that predictably deletes data from a particular table, that's one type of automation. But what if you want to give the ability for other people to do this on a recurring basis or to do this? That's where something like Airflow comes in, right? So here, what do you want to delete, right? Where do you want to delete it? And you want to delete it. You can kind of do the same thing with Scala, Python. Right now, there's not, maybe I'm wrong, DataStax might have put it out, but there's not a way to do kind of scalable deletes in Cassandra in the same way you can do it like here. With Spark. So what we do is we basically say, select the data from this table, go through each partition in a parallelized fashion, go ahead and delete it using CQL. And this is scalable because Spark will go gather all the data that you want to filter from, get it for you, and then it will run these delete operations using CQL and token aware. So you can do millions of deletes on a Cassandra cluster with Spark, and it will be scalable. You can also use Scala and Spark to dedupe information. This is a fairly complicated thing. My colleague Obi found something on Stack Overflow that did it, and we operationalized it into this function. And technically, you can use it for any type of deduping, but this is like for deduping documents in Cassandra. This is a common use case where you have duplicate partitions, duplicate versions, and you want to get rid of anything that is not necessary. This is the type of thing that, again, it's very hard in SQL. And this code is open source, so we'll make sure it's already linked. So you don't have to go reinvent the wheel, right? So cleaning data, deleting it, deduping data, these are common scenarios where we have to do it over and over and over again. And we're not going to go tell a data analyst like, okay, go log into the Spark cluster. Here's to the kingdom. Do your damage, right? What we're going to do is control that situation. And combining baked logic like this with Airflow allows you to control that situation and to give people self-serviceability. Here is a complex data which allows us to move hundreds of tables across hundreds of key spaces at scale, right? And the way it does it is it actually is keeping the metadata for which tables.
And Rahul might have lost your audio. Okay, let me see if I can bring back Rahul. Please bear with me. Let me check what's going on. I know he was having some issues with his network provider, but let me see. Give me a sec. In the meantime, if you're having problems, let me know. We use Skype for an infrastructure, so maybe that's what's going on here. So in the meantime, if any of you are having trouble with setting up the database in Gitpart, please let me know while I try to reach out to Rahul and see if we can get him back. Okay, he said he just got disconnected and he's going to go to the backup line. I'm glad he could do that. If you have any questions, feel free to put it in the chat while we wait for Rahul to come back.
Hey.
Hey, you're back.
Let's see. That's why I have a wireless broadband connection.
Okay. I think you're live already. So cool. If you want to start sharing your presentation, and
yeah,
or otherwise I can bring it up.
I got it. Yeah, thank you. I appreciate that.
No worries.
Sorry about that, folks. I've been having issues with our primary internet provider, and I'm not going to gossip about which ones are good, but that's a different conversation. But anyways, what I wanted to finish this thought is that, look, you can use Airflow for some things, you can use it for complex things. It's just how you put it all together. And, when we do the hands-on, we're doing a very simple operation. But if you can just imagine and think about the complex processes that you have in your organization to get data in, get data out, any recurring processes that you do on big data, that's where we can automate it. So you all should have this repository available to you. This is what Rags was using to get you started. And, I actually, followed along with exactly what Rags did and got my ASTRA CLI set up. So I already have my CLI, but go ahead and bring it up. And what we're going to do is we're going to walk through the Airflow bit. There we go. Just so folks that are new to Gitpod, Gitpod is all based on containers, based on in the background in Kubernetes. So when you're not using your Gitpod, it just kind of like suspends it. But as you can see, that was like 5 seconds and it's back, right? Yeah, this is one of my tokens that I basically dragged in here, And since I'm going to destroy my database, I don't really care. But one of the things to note is that if you have like a file in your desktop, let's say you downloaded the CSV or the JSON token file from here, like I'll show you, right? So here's my ASTRA UI. If I downloaded this file and I put it on my desktop, in fact, I already have this file, so I'm going to override it. I can actually, you don't see it because it's off screen, but I can actually just drag that specific file from my desktop onto my UI in my Gitpart, and it'll be there, right? So anyways, I went ahead and configured my ASTRA CLI earlier. So if you say ASTRA, hold on one second.
Just bring up a new bash. Yeah.
Yeah, that's exactly. Yeah. Well, you know what? I'll go ahead and reset it, reinstall it because it looks like it didn't, keep my change. I didn't commit anything, so that's why.
I think the nice part about again, if you're falling behind in the workshop, is just go back to square A, like what Rahul is doing here. He's just going to install ASTRA again, and no big deal. It should hopefully work. So if you're falling behind, don't worry about it.
Yeah, exactly. So. Yeah. Exactly. So I'm in step 1C, which is install the ASTRA CLI. I've already my database set up, so it'll install everything. And the reason we need to close this is that it goes into the path, right? So like, and so here's one of my terminals, which it's what I'm going to use to install stuff, and then I'm going to run my Airflow commands here. You already have a split screen. But I've got ASTRA in here, right? So what I'm going to do is say, and so I sourced, and if you want to see what that file is, it basically has, where to pick up the CLI, right, and where the home directory is going to be. So I've got ASTRA now in my command. Great. So I'm going to do ASTRA setup. And the ASTRA token, there's one set of tokens for just, when I make the database, and then there's an organizational level token, which I have here. And it's the one that has ASTRA in it, ASTRA CS. And I copied it, and I just right-click, right? And it's going to put that there. And I've got ASTRA set up. And so if I do ASTRA DB list, it's got my two databases. I have this old database that I use for other demonstrations, and I'm using the same exact database name that is in the demo. So I'm doing exactly what's in there. This is the new workshops database that I made. And I made a key space also called Airflow demo. Now, if you didn't have the same exact key space, that's okay. But this command that I'm going to paste, which is also in the documentation, it's going to create in the database this particular key space if it doesn't exist, right? But it already does, so it should be basically.
And for some of you,
so it says, hey,
I know that quite a few of you have attended DataStax Devs workshop, and chances are you may have already created a workshops database. In which case, you really don't need to do anything other than kind of grab the token, right? And then you can create the workspace, because even if you try to create the workshop, it's not going to create it if it's already there. Okay, so all of that instructions are in there.
Perfect. So because we're connecting to a cloud database, we have to have a secure connect bundle, and I'm just pasting the command to download the secure connect bundle for this particular database, and here we go. And this is going to allow us to basically talk to ASTRA securely from our Gitpart. So what are we doing with our demonstration, right? We're going to be getting data into a Cassandra table, or we're going to take it out of that Cassandra table, put it into another Cassandra table using Spark, and we need a table structure, right? We need some tables in there. A key space does not have any data. It's just a container for tables. So we're going to be creating two tables. One is previous employees by job title, and then there's another one, days worked by previous employees by job title. And this is a common scenario. We have to do some roll-ups on some data on a batch process. Maybe you're doing it in real time, but you want to reconcile this information. And so these two tables, we're going to go ahead and create them. You can do it in the GUI, but with ASTRA DB CLI, you can just say, hey, in this table, in this database, go ahead and run this file. And if you're used to SQL-SH,
and
it's
if you
to
created a key space with another name, like, not Airflow demo, you just have to change, the setup to use that particular key space. Not a big deal.
Exactly.
Yeah.
Exactly. So we've got a database, we've got a key space, and we have two tables in there. And you can verify, those tables by, going into SQL-SH on the GUI, and we'll see it in a second. But now we're going to trust the fact that we have these tables in there. And the next thing that we're going to do is we're going to set up Airflow. So it's a simple script. There's many different ways to run Airflow. Okay. This is just running it on one computer, one container. So all the components are here. Okay. And it uses not Postgres, but it uses CQL-Lite, because this is a demonstration. This is a proof of concept type system, right? So you don't have to run Postgres, but it's recommended if you go into production, you do a real database, basically. Maybe somebody will commit code to run Airflow on ASTRA or Cassandra, but right now in production, you need a Postgres database. And the recommendation is, if you're on the cloud, don't run Postgres by yourself, right? Just use like a managed database. Like on DigitalOcean, we use managed Postgres, or on AWS, there's RDS. So what's happening here? We're setting some specific versions for Airflow, because if you don't, happen is it'll download the latest one, and we don't have control over which libraries got downloaded, right? And then once it's installed, it's a Python program, right? So we're just installing Airflow using pip. We have Python on our system, and the DB init will, in our case, make a schema inside SQLite, and then we need a user. We need a first user, an admin user, to be able to log in. The user system is pretty robust. You have roles, you have permissions to give people the ability to just read what's going on, to see what's going on, to to start and stop jobs for a certain set of jobs. But we're going to have a super user. We're not going to get into the role-based access control, but it has a pretty robust system. And once the database is created, once we have a user in there, we run the web server. The web server is what gives us the API ability, as well as the ability to call APIs and UI simultaneously. You can have it. And most people, they forget this. They forget that after you run the web server, you still need the scheduler. So the scheduler is what is kind of like watching out for changes in your files. It's the one that's saying, oh, it's time to go run this job, right? And it's the whole manager for all the stuff that Airflow is doing for you. But you need all these components. You need a database, right? You need a web server, and you need a scheduler. It's actually pretty simple. I mean, when you remember the diagram earlier with the Airflow system, it runs like this between the web server and the scheduler. This is a simple setup. You can have a much more complex setup later on if you want to. So I'm going to go ahead and run. Oops. I'll do that. I'm going to go ahead and run the setup program. And just mind that it's going to download, install, and it's going to ask you for a password. This is a throwaway system. I'm not that concerned. So, I'm just going to have like admin and 1, 2, 3, 4, 5 or whatever. But one of the biggest security vulnerabilities for Airflow was that people were not securing, even after they created a user, a secure user, they weren't protecting this endpoint. Okay. And when we were recommending Airflow at a client, they're like, this software is insecure. I'm like, no, the software is fine. You have to protect the endpoint with a firewall. You can't just put it out there. And that's the thing with any, open source tool. I remember when people were like, oh, Mongo, which I don't like that database, but like Mongo is insecure or Cassandra is insecure because people can just log in using Cassandra. I'm like, yeah, that's true. But anybody that knows what they're doing, they wouldn't just leave Cassandra as a default user. And because you're using ASTRA, you have some security built in already, right? And people can't access that database unless they have the Secure Connect bundle and the token and everything. Okay, so a simple password that I'm not going to forget. And it's going to ask me again.
And you will have to make note of that. So yeah, keep it simple, just because it's throwaway. But I completely agree with you, Rahul.
Yeah.
There is always this balance, right, between getting started and running a production system. It's two different beasts. Yeah.
Yeah, and this setup is, all ephemeral, right? ASTRA is going to store your data, which you can come back to. But, ASTRA databases are serverless. It can get suspended. Gitpart is ephemeral. It starts up when you need it. When you're not using it, it gets suspended. In reality, you're going to have a database that is always running and always has data in and out, so it's not going to get suspended. There are some takeaways in terms of we'll get to that in terms of how I would recommend you use Airflow, but this is just a learning experience, and you can run. You're doing this hands-on. The goal is for you to understand what Airflow is and how to use it. So Airflow is at this point running, okay, and I'm just going to keep this here. I'm not going to turn it off, but we'll notice over here that certain ports are exposed, right? And port 8080 is exposed, and port 8793 is exposed. So if you click on this, it actually shows you the Airflow interface. So I'm just going to log in. And I'm not going to do anything right now, but it gives us some warnings, right? Don't use SQLite in production. It tells you. Oh, he doesn't like my password. It's too simple. That's Chrome telling you that. Do not use sequential executor. So sequential executor just runs the next thing in the system, and then it'll do it. But as I mentioned, there's Celery executor that can do in parallel. There's Kubernetes executor that will just create containers for each job and do it for you. And under the hood, it's using the Kubernetes, job container type, basically, right? Here are example DAGs. Okay, and you don't even have to look at the code in your Gitpod. You can actually just click on this right here, and go to the graph view. And this is a simple thing, but you can start to see, at any given job, or and I call it a job, or DAG is the same. You have different views. The grid basically shows you your previous executions and how long it took, and we'll show that in a second. The graph shows you the current running DAG. In this case, there's only one task. What is scheduled, what is deferred, failed, etc. The calendar shows you previous executions. So if you have a job or a DAG running for years, you can actually see the history. What was the success here? How many were successful? How many failed over the course of a year? Task duration. And okay, when you see all this, you know what? I'm going to wait. I'm going to wait until we're running some real jobs. But before I continue to go to the Spark setup, one thing that's interesting, if you're curious to see what this code is without even looking at Visual Studio in Gitpod, you can see the code right here. Right? It tells you which version of your code is running. So because the scheduler, every 5 minutes, it's watching out for files, okay? And so if you notice that your job is not working as intended, you can just go in here and say, well, what version of my code is running? All right, okay. So we're gonna We're going to put this aside. We're going to come
So Rahul,
back
there is
to,
a question
yeah,
again on chat by Shashikant, who's asking, is Airflow only for data-related ETL jobs, automation, or any other workflows could be created? What are other examples? And Ion, thanks for
sure.
responding. It is not just for ETL. Think of it as
Yeah.
a workflow manager.
Yes, exactly. Thank you, Ian. I appreciate that. So actually, I'll bring this screen back, okay? It's not just for ETL. Anything that is a long-running process that is dependent on other long-running processes, or you have subsequent long-running processes, and you are coordinating it across a distributed system, right? Many, many things, like I want data to come in from S3 into Cassandra. I want data to go from Cassandra into Snowflake DB. I want some Spark job to enhance this information. So you can do the whole kind of range of import, export, processing. You can run machine learning tasks in sequence. So anytime you are doing sequence of tasks with data, you can use it. And this is a relatively new feature, which I have not done a presentation on. But in this case, what it's showing is you can have jobs triggered by S3 events. So in this case, two different S3 data sets, when they get updated, it triggers this DAG, and then that DAG produces this S3 object. Then that gets used subsequently. So this is one kind of DAG where data getting updated will run this, and then so will update this automatically, right? You don't have to do this on a schedule. Same thing here. You have two data sets here. You have another file here, and the outputs are all getting consumed eventually to have two different outputs. So this is an example of it could not just be ETL. It could be, I want to take this information and I want to enhance it. I want to run some machine learning process to classify information. I want to save the data here. Yes, so hopefully that answers your question. Here's an example of a workflow, and actually we have example code where you have a Airflow DAG that will create a Google Dataproc cluster, which is a Spark cluster, okay? And it will create an ASTRA database, and it will go and do some data process with ASTRA on the Spark cluster, and then it can destroy the Spark cluster. So Airflow can actually be used to coordinate some of the infrastructure that you need from an ephemeral basis, right? When you have a long-running job that needs hundreds of computers, you don't want those hundreds of computers running in your Spark cluster. You can use Airflow to say, make me a temporary cluster, run the job, and then go ahead and delete it. Okay. Thank you. I appreciate the question. So we've got Airflow running. We validated that. We also need to run Spark. So I'm going to make another shell here for simplicity. And so this is not the way you would, run Spark in production. But it's, your container, your desktop, this is perfectly fine. Once we run the Spark master, it actually runs a web server that gives us information about where to connect our slave processes. And that's actually, if you look here, it's going to be port 8081. So if you click on this, this is Spark. It's running. And so what we're going to do is we're just going to grab this. This is our local address for our Spark master. And we're going to make note of this, and we're going to use it in a few places. Okay. And I'm just going to drop it in my README for, actually, you know what? I'm going to make a new file called Scratch. I'm going to just drop this in here. And the next thing I'm going to do is I'm going to start a slave process that is going to connect Spark master. And by the way, if you're a user of DataStax Enterprise, you don't have to do any of this. Spark just can come up on the cluster, you enable it, and it takes care of all of this. And technically speaking, you can use Airflow with DataStax Enterprise, right? Because it has Spark, it has Cassandra in it. In fact, we've done a lot of that. So you have here in your master, I'm going to refresh this. It should be coming up soon. What happened here?
No, you did
Oh,
not.
I didn't
Yeah,
press
I was
enter.
going to say,
Let's do a refresh. Takes it a second. Okay, there you go. So we have a worker. You know, in a real environment, you will have 6, 10, 200 workers basically that have their own amount of memory, their own amount of cores. And it's pretty impressive. I mean, I don't know how I got this, but I've got 64 gigs on my container,
Yeah.
so I can do a lot of damage with just this
It's
container.
amazing the things you can do in Gitpart, right? You know, it's like, and
Yeah, this is a lot. I mean, I know you can run Cassandra on this container if you wanted to.
Yeah, some serious stuff.
So we've got Airflow, right? We've got that running. We've got our Spark cluster running. And so the next thing is we want to run a process that is going to run a Spark job for us. And before I get that started, I'm just going to go over the code, right? So we have here a DAG. And I'm going to go over what it's doing, and we're also have some code that is being coordinated by the DAG. So DAG is a directed acyclic graph, right? And this code right here it's a task, right? I have a task that's using this operator, bash operator. You can use a Spark operator. You can use a Google Cloud operator to do specific things. But this is a bash operator that's just running a Spark command. I could run the same exact command on my computer. I could put the same exact command in my cron job, but I'm using a bash operator to do that for me. And in my bash operator, I'm saying, run this version of the connector with my Spark instance, use this properties file, and here's my extract and load Python file, which we'll look at in a second. Here's another task, and I could have many, many tasks defined like this. But the way it knows which one to run for a second is this syntax right here, right? So this job is dependent on this job. And using this syntax, you can create very complex DAGs. So I'll show you one quickly that's a little bit more complex. It's one of the tutorial ones. And I'm going to click on code. Lots of things like extract, transform, and load, right? And it's got all these other, kind of like helpers in here to tell it what the documentation is going to look like. But here's the DAG. The load task is dependent on the transform tag. The transform tag is dependent on the extract tag. Okay. So I'm going to go back to my Spark. So let's take a look at extract and load. So extract and load is a standard Spark Python program. There's nothing special about this. You can run this on any Spark instance connected to Cassandra without an issue. Okay. And this other one, etl.py, again, standard job. Okay. So in our case, in our DAG, load and write is happening first, which is this one, right? Extract and load. And then ETL, which is etl.py, is happening next. So what's happening here? We're doing an extract and load. And we're taking a CSV file, which is here, right? Take a look at the data. It's a little big, right? Lots of data in here. And we're taking it, and we're selecting the data from the CSV data frame, and we're putting it into this data frame, and we're saving it to our Cassandra or instance or ASTRA instance. So how does it know where to put all this? Well, there's a properties file which has this information, and we need to update this to the right one. Okay, so we're going to go back here.
And all of these instructions are on the
consistent.
GitHub repo anyway, so including updating the properties conf file.
Yep.
Just make sure you have
exactly
the details from ASTRA and the master. That's really what you need. Yeah.
That's basically what you need, and you don't have to change this because when we named it exactly this, right? and we have our username and we have our password. And so this information is going to come from that the generated information, right? The generated token. So we've got our client ID and client secret. So I'm going to just go ahead and grab this. Good thing I dropped that file in there, right? It's
Makes
convenient.
it easy, yeah.
You wouldn't leave it in there.
Right.
Don't leave passwords in source control.
Yeah, and you know, even if you have it temporarily, you know, remember not to check them in.
Exactly. In fact, I should put that in the git ignore for
Yes.
leave out any generated tokens. And so it knows essentially, I think it's okay to do this in here. I feel like, yeah. Everything else is set up for you, so you don't have to, you know, mess with it. But you can kind of, it's self-explanatory. There's documentation on the Spark connector on GitHub. DataStax has released that, and then, you know, the rest of the stuff. Again, it's all Spark stuff, but bear with me. This is not a Spark talk. It's about Airflow. I don't want to get too much into details. And so we take the data from the file, put it into the key space name that we have as a configuration property, and we put it into this table. So once it's inside previous employees by job title, the next job will be run for us, which is etl.py. So what etl.py is doing is saying, okay, well, let's go ahead and connect to the key space and the database. And we use this tool to make it easy for us to run Spark SQL. So in Spark SQL, you have to connect it to a catalog. Again, if you're using DataStax Enterprise, you don't have to do any of this. You just go into Spark and you can use it. But what we're doing is we're doing an SQL query that you could not do in CQL. Right? We're running like a legitimate SQL query with some absolute value, with a date difference between the first day and the last day, and it's calculating this for us, right? You couldn't do that. I guess you could, but you wouldn't want to do it in CQL/SH with user-defined functions. And we take that data, and then we save it to this other table, right? That's it. That's all the whole thing is doing. Get data from CSV, dump it into one table, do some calculation, and then put it into another table, right? And you would say, well, you know what? I don't need anything. I could just do it as part of a Spark job. But then what if this needs to happen on a cyclical basis every 6 hours? A cron job is not distributed. It runs only on that one computer. Well, if you have a high availability Airflow setup with Postgres, or Celery, with many, many workers, that job will get executed. No matter what, it will make sure it gets done, right? So we've got our property set up. We know what our DAGs are. But there's one missing piece. In order for Airflow to know about your job, you have to copy this file into the right folder. And this is, I used to be like, why do I have to copy this file? Why doesn't it just look for it? Well, this is what allows you to edit files, play with them, make your changes, and then when you're ready, you copy it. And so from a DevOps perspective, you can set up a process where in GitHub or GitLab, right, you can have a branch that if you do a pull request or a merge request into that branch, they can automatically do what I'm about to do for you. And that's the way we do it, right? A merge request gets approved, it gets copied into the right folder, and all of a sudden the users can start using the DAG. So where does this need to go? There's a folder that we're going to make, which is Airflow is already configured to look for it, but we don't have the folder. And we're going to just say it's, oops, we don't have it in there, so I'm just going to make there. Okay, and I'm going to copy this Spark DAG, which I showed you earlier, to there. So I'm just going to say copy. I'm not going to move it. Okay, you know what? I'll move it. It's okay. That's what the instructions say. I'll do what the instructions say. That
should be okay to copy as well.
Yeah. Okay. I moved it, and what we're going to do is we're going to be waiting on this. We don't want to wait 5 minutes. So what you can do is you can just say refresh. And in a few seconds, we should see our DAG. So how do you know what to look for? So you have named it. very specifically, we have named it as example Cassandra ETL, right? And I can just look for Cassandra because I think, yeah, so I'm just going to go ahead and do refresh a few seconds. And it takes a few seconds sometimes because this is not the high availability version of it, but it does come up. Come on. Give it a second. And while we're waiting for it to come up, we do need to set up a connection inside Airflow. So back here, when we're looking at the DAG, okay, there is a value we were using for the connection, okay? And a connection is basically something that is reused as a variable, but it's a special type of variable. It's a variable that is used for operators that have data in there, okay? But it could be a system or a service as well. So in my, let's see, there we go, where did we go? Anyways, it's a variable in our case, which is like our Spark master default, and we're basically going to set it in Airflow so we can reuse that data later on. Okay, so admin section has variables, configurations, and connections, amongst other things. We're going to go to connections, and right now, it just has yarn, assuming that it's going to run on a Hadoop cluster, but we're going to go ahead and edit this. And we're just going to update the host to our Spark master. Okay. And in the background, what it's done for us, it's kind of set an environment variable. So whenever we're running Spark from Bash, it'll always send it to that particular Spark master. And if you notice, there's many different types of connections: Web HDFS, Redshift, Livy, Cassandra. Right? We're not using Cassandra directly. We're using Spark, but you can connect it to Cassandra cluster. Lots of different existing types of connectors in here. Variables are things that you would use over and over again that are not connections. And then configurations are specifically inside airflow.cfg. So in this case, for security reasons, we're not exposing it. But if you did, you would be able to see the contents of this Airflow CFG. Okay. Remember this, connections. All right. Let's see if our Cassandra job got shown here. Make sure our scheduler. Yep. Okay. It's still running. And it is always kind of like looking in the background to see if there's stuff in here. There we go. I told you. So we can filter it, and if I find the exact thing, it'll bring it up here. So we have now the code that we were looking at earlier in our instance, right? So we've got an ETL job. This is one view. And we have the graph. It's not a complicated job. It's just one and then the next thing. And if I want to double check to make sure, like, is it the right code? Yeah, it looks exactly like the code that I was looking at earlier. Right? So what's the interval? So in this case, we did not put an interval because we want to run this ad hoc. But we can look at other examples to say, well, how could, what does a job look like that I want to run daily, or what I want to run every minute or something like that, right? So these are cron syntaxes. And if I look in here, that is basically being set here, schedule, right? It's one way to set it, or when is the next scheduled instance. So lots to dig deep into the the configuration of a DAG, but I'm just going to go ahead and run my DAG and cross my fingers that it's going to work.
So,
I'm pretty sure it's going to work. Rags and
yeah,
Stefano
okay,
tested the
yeah.
heck out of it.
If you
So-
want, what you can do is you can go to ASTRA and make sure nothing, there are no tables created, right? And then, once it runs, you can show that,
Yeah.
the tables got created. Up to you. Yeah.
Yeah, no, exactly. So, I'm going to run run a command in my ASTRA shell, right? And I'm going to just say select star, right? All right, there's nothing in there.
Yeah.
So we know there's nothing there. The table is there, though. Right? Good. And you can enable and run the job from here, or you can enable and run the job from here if you find it in your big list. So you can enable it. So let's unpause it. And unpausing it won't do anything for us because it's not a schedule to do this in any particular interval. So I'm going to go ahead and trigger it. And I can trigger it as is, or I can trigger it with configuration, meaning I can override certain settings if I wanted it to run slightly differently, like a different table or a different key space. And I haven't written the DAG in a way to take external configuration or external variables like that, but you can do that. It's running, right, in here, and I can go ahead and click this directly, and it's running the DAG, and this is the job that it's running. If I wanted to see review.
So again, Shashikant has a question
Sure.
about Spark to Cassandra integration. Typically in Cassandra, we design tables meant for specific query, right? Which makes absolute sense because you design based on use case. But here we are making any type of SQL query, SQL query. What kind of load does it put on Cassandra?
Great question. And so the way that Spark works with Cassandra, with the Spark connector, is that it is token aware generally. And it will go and it'll say, go to the whole thing with my token ranges, grab the data, and if there's not a predicate, meaning if there's not an index in there, it will pull all the data and it will do the filter on the Spark side. That's the way big data works. If you don't have a way to filter it on the system itself. So if you have a star schema, you can do joins in Spark and there's no load. But when you're doing something like in our case, we're doing a full scan and a full processing and a full save, it's getting all the data, but it breaks apart the work, and it doesn't do a CQL command the way you think about it, right? It's not doing a select star on one computer. It's doing a select star, but it's doing it by token ranges based on the load of that machine, and it grabs it, brings it together, parallelizes the work, does stuff in memory, and then it goes ahead and saves it back. Great question. So unfortunately, but fortunately for us, we hit an error. But what happened? I want to know what happened. So let's take a look at our audit log. And what it's saying is, okay, it started running up here, and there was an issue, I think probably here. So let's take a look at what happened. It said an upstream command failed, right? And I'm going to go ahead back to the graph view, and I'm going to say, what happened here, right? So let's click on this. And I can go to the log for that particular specific task, and it said, please install it. Okay, the example executor requires blah, blah, blah. Okay, fine. I thought we had taken care of it, but that's fine. I'll go ahead and run it. And this is basically, it is related nothing. It has nothing to do with what we're doing. but it's just the Airflow saying, hey, there's an example code here that needs this operator and you don't have it. So we're just going to satisfy that. Okay. And it'll take care of it.
Could it be related to putting that double quotes? I've never tried. I mean, I didn't try it with the double quotes.
I don't think so. So it would have told us this is specifically related for that. Yeah. So what we're going to do is go back to our DAG, trigger it again, and see what happens. And this view, this grid view, is one of the newer views. What it's doing is showing us, hey, this one thing failed, right? And it took 26 seconds. And this other one didn't run because this upstream one failed. So it's like a sequential view of the tasks. And it looks like it's working. It didn't fail yet.
Yeah, we'll see.
Hopefully it's fine. And yep, still gave us an error. So let's take a look. Let's take a look. And this is the part where, Airflow starts to really give us the value of it's managing this work for us. Let's see. Enter root location. Let's see. Okay. Yeah. So you're right. Yeah, you may be. Let's go back and change this to. There we go. And we've saved our file. We haven't made any changes to our Spark DAG, right? So we should be fine. And then go back. And let's hit back here. And I can just go ahead and run, right? I don't even have to go to the trigger. I can just say run. Oh, that only works with this, so fine. We'll have to run the whole thing. Because it is basically saying I can run that particular task for you right now. But in this case, because that's only a feature, it didn't work. So let's see. I got third run. Running, it's running. Yeah, and that CSV has a lot of stuff in there. So it's not a, it's not a small file.
Fingers crossed.
Yeah. Yeah, good. So this means that actually it's doing stuff. And, while that's running, we can look at task duration, right? So, how long did this thing take? Over time, you get to see ups and downs for a particular, job. And then you can see for the last 100 runs or the last 365 run, it also shows you, if you have configured it, how many retries did it take for a particular task. And you can configure that. You can say this particular task, go up to 5 times, go up to 10 times. And that's just a part of the function that you wrap your command in, okay? Landing times, how long did it take overall, right? In this case, took about 63 seconds, which means that something is finished, right? So the first step finished, and then the second step has started, right? Taking some time. Remember, it's not a lot of information, but it's big enough for you to understand the value of Spark, And so this whole thing was successful. So if I go to the graph view, I can see these are green. Good, green is good. And I'm not just talking about American dollars. And if I look for, actually, I want to see it in the master view here. Let's just scroll down to. There we go. So here you go. So it shows us a history on the dashboard of, hey, there were some failures, right? And there's 0 running, how many successes there were, and how many are queued up. And that's what these mean. Queued, success, running, and failed. And then these are basically telling you what is the number of statuses. So there's been 2 successes, 0 deferred. So I could continue doing this here. I could jump directly to one of these interfaces. So this master view is actually a nice shortcut to see what you need and get to exactly what you need to run. So if there was an error, I could just say, go to the graph view, click on it, go to the log, right? And that's it. That's Airflow for you to be able to organize your tasks and execute them. Let's verify, first of all, that did this do what we wanted it to do. So in my other
Cassandra, right?
dash, yep, we moved the data to Cassandra, and we then processed it from Cassandra into another Cassandra table. This is one command. This is the data that we inputted from the CSV file. And then the data that we processed into the days worked by previous employees by job title, right? So coming back to Srikant's question, right? These 2 tables were designed in the way that Cassandra tables should be designed. And Spark is doing the hard work of materializing this view.
So basically, you need to keep the partition key in mind when you're designing the tables, correct? With Cassandra.
Exactly. So this is the demonstration. We have a lot of examples on our GitHub. In fact, I'll show you I'll go back to the presentation so that I can walk you through, what are the examples there. And this is for you guys to play with, right? It's all open source.
And again, if you want to do it yourself, the instructions are there. If you've already set up Gitpart, it'll be around for a little bit. If you want to be sure, you can just pin it and you can try it out, anytime. Unfortunately, we're running out of time, so we'll have to keep going.
Yes, exactly. And here are you go to the github.com/Anant and you just look for Airflow. There's like 7 different repositories about doing different things. Like even one with Cassandra and Presto, one with DBT, the one I mentioned with Google Dataproc and Astra, one that uses Amundsen with Cassandra. So lots of other examples for you to take a look at. Quick things, you don't have to run your own Spark. Okay, just think about it. If you're running complex Spark jobs on hundreds and hundreds of jobs, managing your Spark cluster is tough. So think about using a managed one. Not all Spark code is created equal. Don't let anybody just say, here's my Spark job. Can you put it as an automation? If you have a compiled Spark job, it allows you to have control over the quality of that Spark job. On the Airflow side, you don't have to run it by yourself. If you don't want to, you can run it on Google Composer, managed workspace, managed workflows for Apache Airflow from Amazon, and then Astronomer makes it easy to use on any cloud. Not all DAGs just work. So sometimes you really have to think about different stacks, different applications, different customers in terms of inside the organization. Sometimes you may have to have different Airflow instances for security reason. The same DAG may to see, is it running okay, right? And we may have to put some retries in there. It's not a set it and forget it. But once you figure this out, it is a set it and forget it. Key takeaways, don't reinvent the wheel. Use Apache Spark. Like literally, that's the best tool for big data operations on Cassandra. You can do other stuff, but Apache Spark is a very common way of doing it. Use a scheduler. So Apache Airflow with Python and Python Spark is a very quick and iterative process to do these things, right? You notice I can make a code change, copy it, and then run it. And then once it's baked in, I can maybe think about a compile job as well. Thank you. And I'm going to pass it back to Rex.
All right. So I know that we are going to do Mentee, and we are almost there. And what we're going to do here is, usually we have a form where you can submit your, winners of Mentee. But what we're going to do here is you're going to mail it to Rahul. It's SINGH, correct?
Yeah,
Singh.
Rahul.Singh.
Yeah, Rahul.Singh at Anand.us. Okay, and And you can put it in chat as well, just to make sure that it's there. And it's really a cool looking shirt there, architect, as you can see.
Yeah.
Okay, all right. So let me grab the screen. All right, and let me make sure that you are okay. That's good. All right. So we are just about to jump to Mentee. You just give me a second so that I'll be ready to go. All right. And okay, quiz time. You guys ready? Please feel free to join again if you haven't. 3518069. Okay. And I'm going to put this 3518069. Oh, I don't have the. Yeah,
it's still showing my
apologies there. What did I do? Okay, there you go. So it's 3518069. Okay, and let me start the quiz music just to have a little bit of fun. If it's too loud, let me know. I will try to turn it down a little bit. Okay, you guys ready? Again, 3518069. Let me see where I am. Okay. All right. We have a few people joining. Question number 1 of 6. And Rahul, did I lose you or are you still around? Looks like we lost Rahul again. Give it a second and I'll make sure that he's going to be joining. In the meantime, you people can join in. Looks like Rahul has some connection issues again. Rahul, you may be on mute. That's what I see here. Let me make sure Rahul is there. Otherwise, we can just proceed. If it. Okay, question number 1. You guys ready? Again, for those of you who are joining, there are quite a few who are there. All right. So, very first question. Answer fast, but most importantly, answer it correctly. DBAS that we use today. Pretty straightforward question. Is it Hadoop? Is it ASTRA? Is it Gitpart? Is it none? Remember, it's a database as a service that we use today. What did we use today? We did not use anything, or did we use Gitpart? Did we use ASTRA or Hadoop? Which one of these is a DB as a service? I'm sure we used all of them, right? All right. Nobody got it wrong, which is cool, but let's see how fast people answer it. Rahul is back.
Yeah.
Perfect. Okay. Joker is the fastest.
Nice.
All right, cool. But it could be anybody's game. Simba, Shashi, Mars, Ajay, Ricardo, Shaurya, anybody. Okay? Moving on. Next question. Question 2 of 6. Answer fast, but make sure you get it right. Which of the following is not a characteristic of ASTRA? It's Apache Cassandra in the cloud. It's cloud agnostic. Is it single tenant? And there is no free tier. Remember, this is a little bit backwards question. So let's see how people are going to answer this. Perfect! I think I made it too easy. This is not good.
Nice. Nice.
Yeah, this is not good. All right, let's see. Who got it first? Again, you got to be fast, right? And I think Nick was the fastest.
Nice.
Yeah.
Good job, Nick.
Yeah.
I think it's our Nick. It's funny. At Cassandra Day, we were doing this, and I was playing against Mick, the PMC of Apache Cassandra,
Yeah.
and we were just like, that was fun.
Nick is fast. All right. Now we go to more, tough questions. What is Apache Airflow? Is it a workflow tool to manage any ETL operation and data pipeline, or is it an infrastructure as code tool? Is it really a big data framework, or is it stream processing? Let's see. All right, time's up. And man, we can't seem to stump our audience here. I was hoping at least we would get some wrong, right? Our audience is really getting everything here. It's cool. It's basically a workflow.
Well, it means that we did a good job.
Exactly.
It means that we actually got ideas across.
But we failed in setting the questions to be a little bit tough, right? We'll see. We'll see how it progresses. But maybe there is a change to the leaderboard. That's it. Might be, right? Maybe not. Nick was still the fastest. Wow. That's cool. And Joker is still in contention, so we'll see how it goes.
Yeah.
Okay. All right. Let's see. We have 3 more questions. 4, 5, and 6. Answer fast, but most importantly, get it right. Is it an ATL tool? This is I think it's a tough question in my opinion. Even though answers are very straightforward, right? Is it really an ATL tool? Maybe not. Could be, should be. It's confusing.
I was talking to Rags earlier. It's like, can Cassandra be a queue? Should it be a queue?
Exactly. Yeah. So I'll let you, Rahul. You talk about this.
Yeah. So I'm glad that some people were thinking that it is an ETL tool, or it could be. The thing is that Airflow's purpose is not to do the ETL. Your code is doing the ETL. Your code is doing the extraction. Your code is doing the transformation. What it's doing for you is it's wrapping it. It's like a cron job. Can you use cron jobs for doing ETL?
Yeah.
Exactly. It's just scheduling it. Exactly.
Perfect.
Yep.
Okay. At least we managed to stump a few people. Let's see if there's big changes. Looks like it. Joker reestablishes the lead. Ajay was the fastest, but it could be anybody's game, including Santa. I'm rooting for Santa in December, right? So let's see. All right.
Nice.
5 or 6. We have 2 more. What is not a component of Airflow? You saw a bunch of these. Was it database, schema manager, worker, scheduler, which is again not a component of Airflow? 2, 1. Time's up. This got totally distributed, huh? Maybe not. Yeah. Maybe it's the same 7 who got it right? So the schema manager is not a component of Airflow, and I don't think we ever talked about that, right? So, anything you want to add there, or?
Yeah, you can consider part of your data operations that at some point you have to make schema changes, right? And it is possible to do a schema change and do a migration with Airflow, right? But Airflow is not doing that for you. It's not managing the tables and columns and stuff for you. And it would take a lot of work to kind of rig it to do that. So it's just definitely not part of the whole Airflow feature set.
Last question for all the marbles. Let's see how is it Shaurya is going to be in the lead? Maybe. Just edging out Joker, it looks like. But it's still anybody's game. Nick, who's the fastest, could still jump in there. Last question. Question 6 of 6. All right. You know the drill. How can you reuse the same database or system without hard coding the values? This seems like a tough one, right? Is it using dataset? Is it using configuration? Is it using setting? Is it using connection? I don't know if, Rahul, you talked about this, right? I think you did. You said, pay attention.
Yeah, I did. Yeah.
And the answer is, it's connection actually, right? And 8 people got it wrong.
Yes. Wow. Very few people got that right. I mean, that was
It
a game
was,
changer.
right? So I guess, could you do it with the configuration?
Yeah. So in a configuration in Airflow is an Airflow configuration, meaning what it takes to run Airflow. So it's definitely not that. Now, there are data sets which we saw, which are like, how do you connect data sets to jobs? But tends to be that is a object that can be then fed by a connection. In a setting, again, the setting is very generic. It's really just top level Airflow setting, which you can say setting and configuration is synonymous. But the right approach for reusing the same database or connection string is in connections. And in fact, in the database world, we say connection string, right? And that's what the connection is for, connecting to an existing system that you're going to reuse over and over again. And having it in a place, if you can think about it, you have a development environment, you have a production environment, you can have the same connection token in Airflow and then have your users practice in a dev environment against the dev connections. And then when their code goes to the higher environment, it would be using a production token. Yeah, production.
Perfect.
Connection.
So I know we saved the hardest for the last, right? But everybody's eagerly waiting for who's the winner. Let's see. All right.
Nice. Wow, Simba came in from
Fantastic.
behind.
Shaurya, Joker,
let's
and
see if it-
Ajay, congratulations. What I want.
Good job.
So what I would like you,
Awesome.
the top 3 to do, are you going to give out 3 t-shirts or? Yeah.
Yep,
Yeah.
3
So
t-shirts.
3
Yep.
of them, that is Shaurya, Joker, and Ajay win the cool looking architect shirts. And I will let you know in a moment how you can do that. But please take a screenshot of this. We don't want you giving a screenshot somewhere else, but take it on your device, okay? Take it on your device where it tells you you're the winner, okay? So don't take a screenshot of this. I'm sorry, I was wrong. Okay, so take a screenshot on your device and save it for a moment, and then we will let you know how to get your swag, okay? With that said, a couple of things in Mentee. We'd like to get your feedback. How would you like to improve our next workshop? For instance, we need to be on time, but there was a lot of material to cover, and it's not like we have taken too long, but hopefully it's been enjoyable so far. Please put in what you'd like us to improve, okay? Or with that, we thank you for the Mentee. All right, so now moving on to the presentation. What you will do is take a screenshot of your Mentee screen, right? Congratulations again to the first, second, and third place. And send it to, and I'll put it in here. I'll put it in chat. I think it should be there. If you just do a swag, you should be able to find it. Let's see if it works. Thanks, Shaurya.
And if I have some extra data stacks, glass cups, the steel cups, I'll send those along too. We have a lot of extra ones from before, so.
Cool. Is it Rahul at Anant.us? Does that work? Maybe I got it wrong. Okay.
Yep.
All right.
Yeah. No, definitely.
Okay, and if you want that again, just put in exclamation swag, and you'll be able to see. Again, for more detailed discussions, jump on Discord, and there are lots of people answering questions. I don't know if you are on Discord, Rahul, but
I'll get on there.
Yeah.
I'll
and
watch.
you can watch out for anything else. We do have a lot of workshops, Wednesday workshops. I know that Ian, I think, mentioned that he's going to be back. But others, please free to join as well. We have a Cassandra Summit, and it's coming up on March 13th, 14th. I know I've been working with Rahul to get him to do some submissions. I don't know if you already did, Rahul. Otherwise, treat this as, nagging you here. Okay. But CFP closes in about 3 or 4 days. So don't be left out. Put in a submission. And we're going to build on the momentum that we've had with the community, and this is going to be happening March 13th, 14th at San Jose. There's going to be a training day followed by a number of different sessions, not just by data stacks, but pretty much by the entire community. And with that said, I want to thank you all very much. Thank you. And we are off.
Thank you, Rags, for having us.
Perfect.
Appreciate it.
And as always, don't forget to click that subscribe button and ring that bell to get notifications for all of our future upcoming.
Imagine a being gifted with powers from the goddess of Cassandra, who grew those powers until she could multiply at will, move with limitless speed, and unmask hidden knowledge. With those powers, she was able to fully understand the connectedness of the world. What she saw was a world in need of understanding. From that day forward, she sought to bestow her powers on all who came into contact with her, empowering them to achieve wondrous feats.